Hello everybody and welcome to another shader graph tutorial. In this tutorial we are going to look at this procedural brick texture, which you can change some stuff like this. How much does the noise affect the as you can see the outlines of the brick, and what's the scale of the noise, what's the tiling obviously, and what do we have, range offsets. So this is without random offset and this is with, and you have the base color, and then you have the random change on that base color, and you have obviously the fill color too, and you can change the random range of the height of each one of these bricks, as you can see. You can obviously add other parameters as I will show you now. Let's just jump into the graph, zoom in. All right, what I started with is a tiling parameter vector1 and multiplied it by 2 for the y, so that it squishes on the y basically, because that's the only way I could fit these together basically, and so excuse me, the x is just the tiling and the y is double that, which goes to the tiling of the tiling and offset node. All right, and then here we are adding the offset for the columns, and so I wanted to have the same value for basically, if you noticed, these two have the same offset, but then the ones between have different offsets, and you can do that using a modulo. If you get module by 2, it means that if the floor is divided by 2, then you will get an output of 0. You can see this, right? So you will have 0 and then 1, 0, 1, 0, 1. Because if the value is divided by 2, then module 2, it's going to be 0. And if it is not divided by 2, it's going to give you 1. And it's going to do the same thing for the columns as well, right? And then I'm just going to multiply this value by the base floor, right? And so I think it should be 0 and then 1 multiplied by 1. And then here it's going to be like 3 multiplied by 1, etc. Right, and then so as I mentioned, you will have these all 0, 0, 0, right? Which means it's not gonna, it's gonna be the same place, right? We will get the y of that value as the seed of the random range node. So you can see you will get lines of zeros and then other lines of different seed, which means different output of this random. And this is just the random offset range, 0.5 minus that, and then 0.5 plus that, which is going to be the min and max. And then we are going to construct a vector 2, which will be, we will add this value on the x only, because these columns need to move on the x only, right? So that's adding the offset. Now after that, there are a couple of things. Let's start with the actual brick construction. So here we have tiling, the same parameter connected to the tiling without squishing on the y-axis, because this is going to be our gradient. for like the stuff that will change the outline of each brick. And we have the noise scale here, and then we are gonna multiply the output by noise edge, which is how much it will affect our edge of each brick. And then we are going to add that to our original UV, right? And then we do a fraction so that it repeats, and we connect that to the UV of a rounded rectangle node, right? We also get the floor of the UV, which will give us a like 0, 1, 2, 3, etc. so that we can use it for the seed of a random range node, and it's going to be, well, for each the parameter. I found that the width doesn't really need to be parameterized, but you can do it just the same way I did the parameters for the height. You can see we have random height range, and then I'm subtracting this value from 0.8 and adding it to 0.8, and one is going to be the minimum, one is going to be the maximum, and it's just going to go to the height. You can do the same for these values. I just have these values because they look bright, but yeah, if you are happy with it, you can just stay with this stuff. The radius is how much I can show you. You can see how much radius is on the edges of each brick, basically, to make it smooth. All right, and excuse me. Now we have our bricks basically constructed. We need colors, and what we are going to do is have a base color as a parameter, and then again we're going to use the same floor as the seed of a random range, and it's going to be between our random color, and because we have it between 0 and 1, then we can do 1 minus, so 1 minus 0 is going to be 1, so the minimum is 1, and the maximum is going to be 1 plus 2, which is 3, and then we are going to multiply them, and as you can see you will get this result. And then we are just going to use a lerp based on this stuff. We are going to lerp between our fill color, which is the stuff between the bricks, and the brick color, right? Now here I have this detailed noise, which is basically a construction of 3 different noise scales. You can see this is just the noise scale, and then another one multiplied by 2, and another one multiplied by 4, and I'm getting half of the first one plus 0.35 of the second one plus 0.15 of the third one, just adding them all together to have a detailed noise texture, right? Now you can skip all of this and just have like a texture of detailed noise, but I wanted to make it all procedural, so this is that. Alright, and then we will blend the base stuff with that noise texture. I used a blend node with 0.3 opacity. You can change the opacity to have more or less of this stuff, and I used overlay as the mode, and that's going to be our output for the albedo. And for the normal map, you can use normal from height for this guy, and then normal from height for the detail stuff, and then you can blend these two normal maps using this normal blend node and just connect it to a normal node. You can also obviously use the same texture, this guy, to do a lerp between different values for the smoothness, but I just found it to be fine like this, right? If you want the brick to be more reflective than the fill, for example, then you can use that. But yeah, that's it. Thank you so much for watching, and hit that like button if you liked it, and don't forget to subscribe and check the assets in the description. Thanks so much for watching. Have a nice one.